and then there's the last page that you have to do like a band. It's really easy. It's like, I thought I was done. I think some sort of sense.
Also, Alyssa Nelson, please come to the office, and Cassidy Goodwin.
It's like 10 feet down the hall.
So Cassie, you hear that? Okay.
I didn't study it all. Honestly.
I can't move you because I'm in between. You're like
This part.
you're like a big round. Hey, Tyler's not doing did you just say hi burger?
Hey,
Hi, Jonah.
there's my
Hi,
DNF.
Dirk.
Yeah.
Tommy.
Well, you did DNF?
Tyler's not doing much on this year.
Tyler, you didn't finish?
No, I didn't.
Why not?
Neither did I, too.
Just kidding.
It's alright, Tyler, I never finished.
Did not finish.
I mean, it's
all.
alright.
Ah!
You don't even do any action, Jonah.
Oh.
Not finished what?
Jonah, I honestly.
Ah! Hey, sometimes the truths are right.
Hey, Tio,
I got answers.
when you get results,
About
send
what?
it my way.
I didn't even try it.
How far did you make it? You make it the third
I
mile?
could have found it.
Did you make it to the third mile?
I was like at the 2.5 mile.
What?
I got into like stop. I was like,
What was your pace? What were your 2
my
miles?
first
Were
mile was like 5:50 something. And my second mile was like probably 14 because like after the first mile it was like it feels like it's like
you feeling better though, or not?
Words. Not even really, it's just letters. Every word. Yeah, really.
Play. Alright, hey, we had homework due today?
So make sure that's out is coming up here. It's page 43. Make sure that's getting turned in. I know a lot of people had it done yesterday, but just want to make sure it's done. Okay,
If it's not done, can we still turn it in?
I want it turned in. Yep.
Okay, then it's not late, right?
Okay, perfect. Name's on it. Good. So, unless you've already turned in, then no worries there. I think some people turned in yesterday. So that's fine. Thank you. Because remember, I always hand it back. It'll be graded, and then you can always make fixes. I know some people turned in stuff yesterday that they made fixes on. That's good. Ethan Taylor already had yours. You turned in yesterday, so you're fine. Thank you. Thank you. Remember, the homework I handed back to you yesterday. If you want to make fixes, just staple it to the back, and then turn it back in with the original. Okay. That way I can make corrections on it. And then,
How long do we have to do this?
about a week. I don't want to go more than a week because I don't want to grade it after that. Because otherwise, people will turn in the last week of the quarter, and I'm not going to waste 3 days of my life trying to grade it all. So, not going to happen. So,
Did we get to sign it today?
no, just notes today. Just notes. You get a break. Get a break for a while. Probably assignment tomorrow.
I will be
They'll be due
gone.
next week sometime. So,
I'll be gone Friday for 5.
yeah. So, Friday, we just kind of work on practice semester or practice test. That's kind of what we work on.
When's the test?
Test. I think I'm going to move the test to Tuesday next week. I don't like to put it Monday, so it'll be like a Tuesday. The reason why that way we can use Monday to review, and you're not like stressed over the weekend. So that way, because tomorrow we'll get homework. I'll give you some more time. Friday will be the day we work on practice quiz. If you want to call it that. All right. Okay, everyone got everything turned in? Alright, we're missing quite a few today. So. Yeah, we're missing the two middle
Is Star in this class?
Who?
Star?
Yeah.
She went home sick last period.
Oh, did you? Yeah. So, Tyler, Spencer.
Nick is here, I don't know. He's going.
Probably not.
All PE. Alright, so that makes sense. Alright.
Nick can probably go back.
Yeah, Star was looking really rough.
Alright.
No, she was like red.
Here's harmonics gone today.
I'm not PE class.
Yeah, I know. I heard. So,
I'm not.
we're fine.
You're the whole PE class?
You're just in it.
that class.
Just you.
Yes, sir.
Alright.
That's all it takes.
Long days, I went by myself here.
Do
Washington.
you play long days?
I missed it. Maybe I should enjoy that stuff. I love games. I like miles. I love games. I don't like to play 3
Alright. Hey, let's go through a couple notes today. This will be, we're just going to do a few notes. That's it today. Very nice and easy. If you have homework, please turn in. Thanks, Nick. Alright, so here we go. Alright, we're on section P.4. It's the last day of it for actual notes. Remember, the title of the section is Polynomials. So what we talked about yesterday was like the definition of it. We talked about how to actually add, subtract with polynomials where you just combine like terms. Subtracting and to distribute the negative sign, that wasn't a big deal. The big topic that I want to talk about today is multiplying. Okay? I know that a lot of people don't have a problem with finding the product of things, multiplying. But the problem is there's so many different ways you can multiply polynomials together, with the scalar multiplication, just the normal polynomial multiplication. But then we also have exponent rules that I want to talk about. Okay, so that's kind of that's the one thing I do want to discuss today. So we're gonna talk about multiplying. That's gonna be our main topic today. So we're gonna try to get to each of the three. We're gonna try to do scalar multiplication. We'll try to do just normal polynomial multiplication, which I think I just refer to it as like algebraic multiplication because you're gonna have variables in it. Then the big part today is we have to look at the exponent rules. So we have to look at how it would work for an exponent. And this will lead us into a topic that from previous years I've had experience where the classes really have a tough time at first learning the exponent rules. Okay, there's this branching tree that we can use, that I'll kind of hint at today, and we'll see if we can cover it. Then, if we have time today, we'll see. We'll do an example where we look at like area and volume today. Area and volume. We'll see if we can get to that. Okay, so does everyone understand our concept here, what we're gonna talk about? Okay, I think for these first two, we're just gonna do one example. That's all really what we need to do for these two. We're gonna spend some time on this exponent rule today. That's where we'll spend the majority of our time. Okay, does everyone have an understanding of that? Okay, alright. Let's see. Is there anything else I'm missing that we need to cover? I think that's pretty much about it. Yeah, okay, good. So, alright. So let's talk about scalar multiplication. So, let's kind of make up a problem here. 7 minus 3x plus 1x squared. Okay. This is scalar multiplication. It's got the number, the 5 out front. How do we do that again? Distribute. Yeah, that was just the key term that we talked about yesterday, right? You're just going to distribute this 5 to everything. Okay? Now, the reason why you can do that is because on the inside, you actually have a polynomial. There's actually something that you cannot simplify on the inside. Okay? So then you're going to actually take the 5. Now what I mean by that is if you had a problem like this, you don't distribute the 5. Some people they think that they have to take the 5 times the 30, 5 times x, 5 times the y, they try to distribute. You don't. Because this is one item. It's single. So you're actually just doing normal multiplication. Instead of having the parenthesis there, this is the same thing. You could just multiply the 5 times 30. Because the only time you distribute is if there's plus and minus signs in there, and you can't simplify. Or maybe it's a problem like this. Some people think that they have to distribute. No, because you can simplify this. It's one item. This would be 60x squared y. If you actually multiply, then you can take the 5 times that. Single items, if it simplifies, you can do that first. You can do parentheses first, then you can multiply second. It's like order of operations stuff still. But in this case, on this problem here, you just have to. There's nothing I can do in the parentheses. Can't add or subtract anything. So I'm forced to distribute 5. So that's what, 35 minus 15 plus 100 x squared. And you just multiply the 5 to each item. Okay, is there any questions, concerns about that topic? I wanted to cover that, because I know some people, they get distribution happy. You know, they try to distribute over too many things when you're not supposed to. Okay, let's move on to the second topic, polynomial multiplication. So 3x minus 4, x squared plus 7x plus 8. Doesn't matter if it was a trinomial, polynomial, binomials multiplied together, you still have to multiply them. So you still have to learn how to, you can't on this one, we don't use the acronym FOIL, we don't do that. The reason why, you only FOIL when you have binomial times a binomial. In this case, we have a trinomial. So you have to do that rule that I talked about yesterday, where you distribute things one at a time. So that's why I want to do something a little bit bigger than what we had yesterday. I usually color code when I do this, so I'll kind of show you what I'm doing here. But binomial and trinomial, when you're multiplying that, I always think about how many terms I'll have before I start. Okay? So I know that I'm going to multiply and get this big list of stuff written across the board, but how many items will I have? Well, how many are in this parenthesis? 2. How many are in that parenthesis? 3. So that means 2 times 3, I'll have 6 items across the board, if I do it right. Now, do they have the same numbers, or sorry, do they have the same variables and like terms? Somewhat. So I'm figuring on this problem, I'll probably be able to simplify it. Because that parenthesis has x's and numbers, the other parenthesis has x's and numbers, they match, so it has potential to be simplified in the end. Now if this had like an x and a y in it, now there probably is no simplifying at this point, because they have different letters and terms. That's just something I think about before I start. Can I simplify it? Okay, now, let's multiply this through. I'll try to color code as we go. So I'm gonna take this 3x times everything in the back. That's what I'm doing. That's how I multiply. Once I'm through those three items, the x squared, the 7x, and the 8, then I move on to the next item. I'll take the -4 times everything back here, one at a time. This is how I think of the problem. It's distributing twice. Does that make sense to you? Can you see that now? That way you always get the right answer, and you can always figure out like how I'm doing it. I do one at a time, and I write them all out, and I try not to go too quickly. So let's color code. Let's start with the blue ones here. 3x times an x squared.
3x to the third.
3x to the third, right? Because you still add the letters. You still add the variables, right? 3x times the 7x.
21x squared.
21x squared, because you still add the x's together. There's two x's there, right? And then 3x times the 8. 24x. Okay. Is there any questions with the blue items? How I got like powers, numbers? Pretty straightforward. Okay, now we can move on to the red items. The -4 times everything. So -4 times the x squared is -4x squared. -4 times the 7, so -28x's. And then -4 times the 8 is -32. Did I do any math wrong there? Any signs off? No. Okay, we good so far? Yeah, alright. Now I should be able to combine some stuff. Like terms, things that can match. Don't lose anything. The x cubed will go first. I tried to write this in descending order. There's no other x cubes in this problem, so 3x cubed. That's the highest degree item. The squares, I can definitely combine these. 21 minus 4, what is that? 17 x squared. Is that right?
Yeah.
The x's, the plain x's, I can actually subtract those, so I'm gonna have -4 x's. And I think there's only one plain constant, and that's the 32. So there you go, that should find my answer. Do you notice that it did simplify, right? I had 6 items. I had the 3 blue, the 3 red, but then they simplified, and the reason why they did is they had the same variables and numbers, same terms. You can tell that before you start, whether the parentheses match or not. Okay, we good? Alright. Now let's get to the new stuff today, where I need to talk about how exponents work, and then give you 2 different methods of doing this. So this is what we need to spend most of our time on. X plus 8 squared. Different than before. It's not this. This is the problems we had a couple sections ago when we did the laws of exponents, like the second section of prerequisites. On this problem, the rule was we distribute the 2, correct? You distribute the 2 to each, because it was a single item, so you could put the power 2 on each item here. So this is 8 squared and x squared, so this turns out to be 64x squared, right? Fine. That problem's different. The reason being is that that is a binomial in the inside. It's not a monomial, because what this literally means, what the power 2 means, is that you have 2 of the 8 x's being multiplied together. That's what it means, right? You take 2 of the bases, multiply them. That's why it turns out to be this. That's the real math behind it. Over here, don't distribute the power 2. You don't do that. You have to do the real math. You have to actually say that, okay, you have 2 of the bases. I have an x plus 8 times an x plus 8. That's how you do that problem. That's the real math behind it. The reason being is that if you try to distribute, you'll miss the middle term. Because when you FOIL, there's a middle term, right? You'll miss it. Some people will look at that and go, oh, it's x squared plus 64. No, you still have to FOIL, first outer and last. And so when I do this, x times x, x squared, X times the 8 is an 8x. And then I can do it for the second term now. So I'll take the 8 times both items back here. 8 times x, and the 8 times 8. And now you can see that there is a middle to it. It didn't go away, it's still there. And so your final answer on this problem is x squared plus 16x plus 64. Okay, do we see the differences between the exponent rules? For some reason, like, if I didn't warn people of this, they always attempt to do this type of thing, where they just distribute and they don't think about it. Alright, I'm gonna give you a problem right now, and I wanna see what you get for an answer. Okay, I'm just gonna give you a simple problem. I'm gonna let you work on this just for a second. Okay, so take a minute or two, try to write this on your paper. Let's see if you can get to the correct answer in the end. You might need a calculator. If you need one, you can go to the back and borrow one. I have some over there in that little white container. I wanna see if you can figure out this. Sweet. Alright. Is that what you got? Correct? Now, just an honest question. How much work was it? Was it a lot? Like you had to FOIL forever? Did you have to do a lot of like distributing and, okay. Was it a nightmare or was it like, nah, it wasn't too bad? Rough? Just because there's a lot of terms, right? How many terms were there across eventually? There's what? There was 2 times 2, there was 4, and then you took 4 times 2, so there's maybe 8 across. 8 across, and then you simplified maybe? Something like that? So there could have been quite a few terms, but you got down to this, right? Okay, what you're looking at there, what you're looking at over there is my shorthand for doing this problem. It's a shorthand. It's called Pascal's triangle. Have you ever heard of that term? It's an upper level math concept. When I first saw this was in college. It was like a college level calculus course. When I first saw this. I never saw it in high school. My teacher never showed me this. You can see my little Christmas tree here. This Christmas tree keeps going. This is Pascal's triangle right here. This. What this triangle is, it's how you do your problem that you're doing right now, but it shows you what your leading coefficients will be. That's what the Pascal's triangle does. And how I make the triangle, because I don't really memorize it. You do start with 1, then you go 1 and 1, because the outline of the tree just has 1s on it. Then to make, when you go to the next row will have 3 numbers. And how I make the middle numbers, you add the top row, you add these 2 numbers that are side by side, you add them together. So that's 2, right? And there's 1 on the outside because it's a tree. The next row will have 4 numbers, because this one had 3, this one had 4. And so there's 1s on the outside, and then the middle numbers are just add these 2 together. Add these 2 together. 1. Next row will have 5, 1, add these together, add these together, add these together, 1. And what this is what your powers would be. Power of 0, power of 1, power of 2, power of 3, power of 4, power of 5. And so I knew that I had to be in this row. Because what was your power on your parenthesis? 3. That's how I know which row it is. And you can actually see my numbers where they're coming from. The numbers from Pascal's triangle are literally there. There's a 1, there's a 3, there's a 3, there's a 1. Now the inside stuff is what gets people. It's not the triangle. Most people, like when they have this triangle written down in their book, that's fine. But it's actually getting these powers and knowing how to do this that confuses people. This is tough. My goal today is before you leave, to at least try one of these where you can do it by yourself. And I'll explain more of the rules and where these come from. But does everyone see where the tree fits in? Does everyone see like the numbers 1, 3, 1? Okay? Alright, now, obviously what you guys did, or what you were supposed to do if you attempted it, was to write 3 parentheses down. So you had 3 of the bases. And then you FOIL it. Now, how do you FOIL correctly? Do I FOIL this to all of them? Yeah, you FOIL 2 together. Work with the first 2. Get those numbers. There should be 4 numbers there. Then whatever that is, then you FOIL it to the back. That's how I do it. I don't care which one you start with. So if I multiply these together, what you're supposed to do is 3 times 3 is 9x squared. Then 3x times 4 is 12x. And then 4 times 3x is 12x. And then 4 times 4 is 16. And that was the first 2 parentheses. And then you can multiply the last. And then the same exact concept. You take these times each of the items back here, so that's 9 times 3, which is 27, x to the 3rd. 9 times the 4 is 36x squares. So that's the first item times everything. Back now to the 12 times everything. 12 times the 3x is 36x squares, and you guys get the pattern. 48 x's, and so on and so forth. And eventually you get to my answer. Okay? Everyone feel comfortable with multiplying? Now, the reason why I bring this up, why did I even attempt to show you this? Because it is an upper level concept. This course is for pre-calc, right? You're supposed to get some calculus knowledge. At some point this is definitely a calc topic. The reason why is because one of the problems I saw in your textbook was something like that. I think it was this, actually. Whoa. It's a power of 7. It's a power of 7. That means you have 7 of those parentheses. And then you're going to have to FOIL them all out. I would never want to do that. That would take forever. 3 of them took long enough. There was like 8 numbers across the board. Can you imagine a power of 7? It'd be way more. It'd be way more numbers across the board. In fact, how many would that be? Yeah. What is this? Okay, 1, 2, 3, 4, 5, 6, 7. And there was 2 in here, 2 in there, 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 2 in there. So that's 4, 8, 16, 32, 64, 128 terms across the board. If you didn't simplify anything. Like over there, I wasn't simplifying anything. I didn't add the 12 x's together, right? I was just distributing one at a time. Would you want to do 128 terms across the board? No. That would take forever. I saw that problem. Like it was something like that. It was in your textbook. And that was just problem number 50. No. Wouldn't want it. That's why this is the preferred method when you have something like that. And that's, like, trust me, when I was in calc, my high school teacher never taught us this triangle. It's the shorthand for doing that problem. So if you can learn how to do this, if you can learn like where I'm getting these things from, like where do all these little pieces come from, it makes way more sense. Okay? Now, let me explain. I'm going to walk through this problem. Not that one, this one. To show you how did I come up with your answer in like a couple steps. Okay, that's my goal today, so you can at least see this. Alright, so, everyone understand the triangle at least, how I'm doing that? Because you want me to make another row just to show you where the numbers come from?
Yeah.
Okay, let's do one more row just so you can see this. So the next row below, there'll be a 1 out here. You're going to add these together, so this will be a 5. Add these together, that'll be a 10. Add these two together, that'll be a 10. Add these two, that'll make a 5, and then there'll be 1 on the outside. That would be like if I had a power of 5 on my problem. I'd use those. But I'm using powers of 3s, right? My problem has a power of 3 on it. So I know that my leading numbers are going to be 1, 3, 3, and a 1. That's when I know my numbers are going to be. The leading numbers. Okay? Now how it works, you start with the first term, and what you do is you take this, and you put a power of 3 on it. So you put it right behind the 1, you put 3x, and you put a power of 3 on it. Does that make sense? What you're putting behind it, because there's going to be a bunch of things, you take this item, the 4, and you put a power of 0 on it. Put a power of 0 on it. So, because I'm using both items to do this. So 3x cubed, the 4 will have a power of 0 on it. Then you put a plus sign. Make sense so far? Okay, the next item has a 3, right? The 3 just stays there. Behind it, I'm going to use the 3x. I'm going to use the 3x. But now, I'm going to take it down 1 power. Take it down 1 power. So what was the power on the 3x earlier? It was a 3. Take it down 1. So now it's a 2. And the 4 is going to go up a power now. So the 4 will now be a power of 1. 4 to the first power. And then put a plus sign again. And now we keep going. So now I'm going to have a 3x, right? What's the power on the 3x now? Yeah, it's going to go down now. It's going to go down. And the 4 is going to go up. 4 has a power of 2 now. And then the last one, I have the 1 out front, right? That's my lead number. I have the 3x. Now what's my power on the 3x? 0. And the 4 now has a what? Has a 3. Then all I do is I just do the math and I figure out what each of these terms are. 4 to the 0 is literally the number 1, so I don't care about that. There's a 1 out front, and in the middle I have 3x cubed. 3 cubed is 27, x cubed is an x to the 3rd. So when I multiply those together, I get 27x cubed. That's what you had for your answer. Okay? The middle term, this is a 3 out front. This item is a 3 squared, which is a 9, x squared, which is x squared, and then you have a 4 behind it because it's 4 to the 1. And when I multiply these together, 3 times a 9 times a 4, you get 108 x squares, which is, I think, the number you had, correct? This back item, that's a 3, there's another 3 and x because they both have powers of 1 on them, and then the 4 is squared, so that's what, a 16? So 3 times 3 times 16, that turned out to be the 144, and there's an x. And in the back, there's a 1, there's another 1, because 3x to the 0 is a 1, and then a 4 to the power of 3, which is a 64. So 1 times 1 times 64 is a 64. And this is your answer. That's how it works. That's your answer. Do you see how like the bigger item goes first and you count down, the second item goes up in power, that's how it always works. It works the same thing no matter what the powers are. So I could do the same problem, I could put a power 4, and now I just use the bottom rung. So I'll have 5 items across the board. And I'd use that rung. I could do a square, and I would just use this rung. That's the idea. I could do a power 7, and I would use the 7th rung. This is the 5th, so I go 6, and then the 7th rung, eventually. And I could get to that number. And I wouldn't need to do the foiling thing where I have 128 terms across the board. Zowie, that would be tough. I would not want to do that. Okay, does this make sense, like what I'm doing here? Okay, tomorrow, because I know we don't have a lot of time, I think we only have a minute or two here. Let me double check how much time we have. Yeah, we have about a minute. Okay. Tomorrow, we'll try one where we do a bigger power, like maybe power 4 or 5. And we'll try one where we try to practice this. We'll start small. We'll try square. We'll try one with maybe a power 4 or 5. And we'll see if you guys can get that and see if we're good at it. Then we're going to move on to the area and volume problems. We will have homework tomorrow. Okay, does that make sense? You'll have time to work on it in class tomorrow. It won't be a lot. It's not going to be like this last time. That was, I consider that a lot. It was quite a while. But, the stuff we're going to go to, I'm just going to give you maybe 1 or 2 of each. Okay, I'm not going to give you 3 or 4 like that. Okay, so 1 or 2. So you have a couple multiplying, a couple adding. So it'll be more manageable. I'll give you a good weekend to kind of work on it and stuff. Practice test, we'll look at them on Friday, and we'll continue Monday. Okay, that way, because I know some people are gone, they'd like to have some review time. So, make sense? Okay, is anyone going to be gone tomorrow for sure? No, people are gone Friday, I know that. Anyone else on Friday? Just listen.
He's obsessed with volleyball and basketball right now. Like, obsessed. Like, Olympics.
Now, just a question we were just discussing.
Because he's on constantly. We never turn our TV off during the Olympics. It's just on all night. Plays. And he just.
We'll practice it again tomorrow.
He's obsessed with it.